अच्छा जी। सो यहाँ पे जो है ना, इस सेशन में हमने कोशिश करना है कि जितने भी 22 वेरिएंट्स होंगे वो सारे मैं करा रहा हूँ, सही है। सो और हम कोशिश करेंगे कि अगर हमारा एक क्लास में एक पेपर ख़त्म हो जाए देन फाइन, शुरू में थोड़ा टाइम लगेगा, देन हो जाएंगे, सही है। और बाकी ये 2012 से मैंने 22 या 24 तक, मैंने 24 तक मैंने पूरे कराना है, और 22 वेरिएंट, सही है। और बाकी ये होंगे कि 21 23 मैं आप लोग को होमवर्क दूंगा, सही है। और 23 की मैंने ऑलरेडी वीडियोस अपलोड कर रखी हैं, सही है। सो इफ़ यू वांट एनी हेल्प यू कैन चेक आउट द वीडियोस, एंड 21 भी मैं आहिस्ता आहिस्ता अपलोड कर रहा हूँ। सो आज हम भी शुरू करते हैं। सो दिस इज़ मई जून 2012। अच्छा, पहले ज़माने में ना 1 घंटे का पेपर आता था, अब द टाइमिंग फ्रॉम आई थिंक 2016, आई थिंक, हाँ यस, 2016 से टाइमिंग रिवाइज हो गई है, सो वो 1 आवर 15 मिनट का होता है, ओके। चलो, सो दिस इज Kab doing the paper, and center number is 00001 and candidate number is 00001. Okay, let's start. अच्छा, बाय द वे यू हैव टू कीप इन माइंड दैट आपके सिलेबस के अंदर फ्रॉम द कॉन्सेंट यू हैव टू यूज दिस वैल्यू, राइट, जो कि यूज हो रही होगी। एंड देन आपके सिलेबस में ये चीज़ यूज होगी, राइट। एंड देन आपके सिलेबस में ये वाली चीज़ यूज होगी, राइट। एंड देन आपके सिलेबस में मास ऑफ द इलेक्ट्रॉन भी यूज होगा, राइट। And then you have to use this thing, right? These are the four things जो कि आपके syllabus में है, okay? सही, and the rest of the things are of A2, right? तो उसकी आपको टेंशन नहीं लेनी है, सही हो गया। अच्छा, और over here these are the two formulas जो कि हमारे syllabus में है। This formula is in other part of the syllabus, राइट। एंड हमारे पास सीरीज सर्किट के ये दो फार्मूलाज हैं, राइट। एंड द रेस्ट ऑफ द थिंग्स आर फॉर द ए लेवल्स, ओके। बस इतना दिया होगा, होता है आपको। चलो आ जाओ भाई, प्लीज रीड कर लो यार क्वेश्चन। थोड़ा सी मैं रोजे में जो है ना मजदूरी करवाऊंगा, आई एम सो सॉरी, बट थोड़ी सी करनी पड़ेगी यार।
The volume V of liquid flowing in time 3 through a pipe of radius r is given by the equation V over T is equals to pi PR to the power of 4 over 8 CL, where P is the pressure difference between the ends of the pipe of length L and C depends on the frictional effects of the liquid. An experiment is performed to determine C. The measurements made are shown in figure 1.1. Calculate the value of C.
कैलकुलेट द वैल्यू, ओके, स्ट्रेट फॉरवर्ड क्वेश्चन है। यस, यू जस्ट नीड टू मेक सी द सब्जेक्ट। सो मेकिंग सी द सब्जेक्ट, पाई पी आर स्क्वायर डिवाइडेड बाय 8 times 8 v over t, okay। I'm writing the whole thing down क्योंकि if you send t to in the numerator and v in the denominator, then this value will be changed, okay। वो 1 over आंसर करना पड़ेगा, 1 over this value करना पड़ेगा, so I'm not doing that, okay। Now pi की वैल्यू आप रख लोगे, right। So p has a value of 2.5 exponent 3, you have to be very careful with the powers, power of 10 basically, and r is going to be 0.75, and it is in millimeters, so you have to convert it into meters and divide it by length का भी, ओके। सी, अच्छा वहाँ पे लेंथ भी है, ओके। यहाँ पे लेंथ भी आनी चाहिए। 8 टाइम्स लेंथ हमारे पास आ रही है 0.25 मीटर्स के अंदर, एंड वी ओवर टी हमारे पास आ रहा है 1.2 एक्सपोनेंट -6, ओके। प्लीज कैलकुलेट कर दो।
So 2.4 exponent 6.
2.4 एक्सपोनेंट 6, अच्छा जी। ओए, 1.04 एक्सपोनेंट -3 देयर -3, wait,
Circle.
can,
So I put the same values.
wait, I didn't put the fourth root, ओके दे, अच्छा ये स्क्वायर नहीं है, ये पावर 4 है, एंड ये पावर 4 है। अब कर लो, अब सही हो जाएगा।
Yes, sir. 1 times exponent negative 3.
ओके, 1.0 एक्सपोनेंट -3। परफेक्ट, आगे आ जाओ।
Calculate the uncertainty in C.
अनसर्टेनिटी इन सी, ओके फाइन। सो सिंस वी हैव अ लॉट ऑफ क्वांटिटीज, हमें सबसे पहले जो है ना वो कॉन्स्टेंट्स को इग्नोर करना है। सही, एंड सी को सब्जेक्ट बना के कॉन्स्टेंट्स इग्नोर कर दो। सो percentage uncertainty in C should be equal to the percentage uncertainty in P plus 4 times the percentage uncertainty in R plus percentage uncertainty in V over T, right? Plus the percentage uncertainty in L, right? ये equation बन जाएगी। एंड अच्छा जनाब, then percentage uncertainty in um, power is going to be 0.05, or okay, so 0.05 divided by 2.5 into 100, right? This is the first thing. Then 4 times R is given as 0.01 divided by 0.75, and plus VT has an uncertainty of 0.01 divided by 1.2। ओके, यहाँ पे आपको जो है ना उसकी टेंशन नहीं लेनी है, राइट? मतलब कन्वर्जन की टेंशन नहीं लेनी है, क्योंकि यहाँ पे कन्वर्जन की कोई ज़रूरत नहीं होने वाली है। ओके, अच्छा जनाब, थोड़ा सा दूर कर देते हैं। इंटू 100 भी यहाँ पे लग रहा है, सही है। एंड प्लस मेरे पास है एल विच हैज़ अ लेंथ ऑफ 0.001, 0.001 डिवाइडेड बाय 0.25, 0.25, ओके, इंटू 100। निकाल दो भाई, कितना आता है? ओके
Sir,
बैन,
10.78.
3 नंबर देना, ओके सही। सो द परसेंटेज uncertainty in C is 10.78। ओके, नाउ you have to find out the absolute uncertainty in it। सही है, क्योंकि इन्होंने जस्ट एब्सोल्यूट अनसर्टेनिटी की ही बात की हुई है। सही है, सो अगर हम उसकी वैल्यू निकालें तो उसके लिए आप कह सकते हो कि चलिए उसके लिए हम कह सकते हैं कि भाई वेट, सो डेल्टा, वेट, percentage uncertainty in C should be equal to delta C over C into 100, right? So percentage uncertainty is given as 10.78, उसको आप जो है ना वो डिवाइड कर दो 100 से और सॉल्व कर लो। सो 10.78 divided by 100, right? And times it by C की जो भी वैल्यू आई है 1.04 आ रही थी, 1.04 exponent -3, सही है। So you'll get the delta C, how much?
Sir, 1.12 exponent negative 4. So like 0.001.2, I think.
0.00, पक्की बात है? Wait, they are getting this answer, they are getting 8.6 not 10। इसका मतलब है आपने ये थोड़ी सी गलत की है। ओके, कर लेते हैं भाई। +4 से मल्टीप्लाई किया था, 0.01 डिवाइडेड बाय 0.75 इंटू 100, राइट? एंड प्लस 0.01 divided by 1.2 into 100, right? Then plus 0.001 divided by 0.25 into 100, I'm getting 8.567 exact. Are you getting
So just 6 and
.567? Okay.
so I got 8.567. Yeah, now I'm getting it correct.
Okay. So now, just change this value 8.567 and divided by 100 into 1.04 exponent negative 3. So I'm getting 8.9 exponent negative 5. Okay. So
Yes, I'm getting the same thing.
perfect. 8.9 exponent negative 5. Fine. Okay. And
So, but we're not supposed to write
we're not supposed to write.
in standard form, right? Because it's
Why?
uncertainty.
No, वो यहाँ पे होगा, इधर प्रॉब्लम होगा, राइट?
Geo.
अच्छा, मैंने ना इसकी मार्किंग की देखनी, एग्जामिनर रिपोर्ट दिखानी है मैंने कि एग्जामिनर क्या कहता है इस टाइप के क्वेश्चन पे, राइट? सो पहले तो इसको निकालते हैं। अच्छा, सो अब अगर हम यहाँ पे इसने कहा स्टेट द वैल्यू ऑफ सी एंड इट्स अनसर्टेनिटी टू द अप्रोप्रिएट नंबर ऑफ सिग्निफिकेंट फिगर। सो ओवर हियर यू शुड नो दैट द एब्सोल्यूट अनसर्टेनिटी शुड ऑलवेज बी इन 1 SF, okay? So if this is if this is 8.9 exponent 5 and this is exponent negative 3, so just make it exponent negative 3, so this becomes 0.0089 exponent negative 3, right? So we first have to make the standard form same. So this is the same standard form, right? So now I have to write 0.009 only because एक मिनट एक दो वेट, एक दो तीन तो पाँच नहीं, सॉरी गलत हो गया, एक एक जीरो कम होगा इसमें, एक जीरो कम होगा, सॉरी। ये हो जाएगा 0 इस तरह से होगा, सही है। सो so I have to write 0.09, right, for the uncertainty and exponent negative 3, right? क्योंकि it should be in 1SF, right? It should be in 1SF, right? First thing. Now count the number of decimal places it has. So two decimal places, right? So your value of C should have two decimal places. Okay, 1.0 and 4 exponent negative, and यहाँ पे भी 4 आ रहा होगा, right? So but खैर वो हमने ignore किया है, exponent negative 3. Okay, is that clear? Yes.
Yes.
Okay, perfect. अच्छा, इसकी ना एग्जामिनर रिपोर्ट देख लेते हैं कि एग्जामिनर क्या कहता है। ओके जी, ये क्वेश्चन बने, एक मिनट, यही पेपर है। 21 21। ओके, this was answered correctly by almost all the candidate. The majority of the answer were expressed clearly. Credit were lost where the candidate changed the power of 10 by crossing out or altering what they had written, making their final answer eligible. Okay. Okay, candidates should be advised. अच्छा, वन का पार्ट बी, वन का पार्ट बी, दिस वन जिसमें उसने अनसर्टेनिटी निकलवाई। ओके, so candidates should be advised to give the base unit of each quantity. What the hell, man? 22 है यार, come on, sorry, 22. Okay, yeah, yeah. So majority of the candidate made error in the calculation. Okay, whoa, because it has a lot of power of tens, right? The main error were to omit one or all of the required power of 10. Look, so yeah, for three of the substitution made from figure 1.1, right? Which table के अंदर they have given you a lot of power of 10, so you have to include them as well, right? To okay, power of 10. Some made the rounding error in the answer for C, giving this instead of that. Okay, so power, okay, we are also not allowed to give the answer to 1.0, we still have to give the answer 1.04. Okay, is that clear? So you should have to write the answer to 1.04. Okay, now
Wait, sir. The value of C and the uncertainty of C, should they be in the same power?
actually yes. Otherwise, it would be difficult for you to decide the number of SF. Okay, clear?
Okay.
ओके सो और एग्जामिनर रिपोर्ट देख लेते हैं इसकी। एक तो ये चीज़ हो गई। अच्छा, दूसरी ये चीज़ है, ये प्रॉब्लमेटिक है। अ सिग्निफिकेंट नंबर ऑफ कैंडिडेट इंक्लूड द फ्रैक्शनल और परसेंटेज अनसर्टिनिटी फॉर द फोर टर्म इन्वॉल्व। ओके, हमने भी यही किया है। एंड एरर वर मेड बाय नॉट एडिंग all of the 4 percentage uncertainty or by including the power of 10 in the denominator. Okay, so मैंने भी कहा कि we are not allowed, we are not supposed to add the power of 10 in the denominator. So if you're adding, so you have to add in the numerator and denominator both, right? Okay जनाब, but not in the numerator, right? इन्होंने ये भी लिखा हुआ है, right? So if you are adding, then you should have to add both the numerator and the denominator, right? The actual uncertainty, okay, fine. अच्छा जी, the factor of the four in the fractional uncertainty if the radius was included by a large number of candidates, a significant minority gave the percentage uncertainty as their final answers. These candidates do not apply their answers to A to obtain the uncertainty in C. Okay. Then they're saying the answer was often given incorrectly with more than one significant figure for uncertainty or the power of 10 included in one term but not the other. Okay. Clear हो गया? Iman, is that clear? This is what you were saying, है ना? You have to give the power of 10 for both the error and the quantities should be same. Okay. सही हो गया ना? मतलब इसका भी 3 होना चाहिए and this also has to be 3, right? and अगर इसकी मार्किंग की चेक करो आप, so the marking की, okay, the marking की also is also saying this way. Clear? Yes,
Yes.
perfect. आगे आ जाओ भाई, आगे रीड कर लो।
A ball is thrown vertically downwards towards the ground and rebounds as illustrated in figure 2.1. As the ball passes A, it has a speed of 8.4. The height of A is 5 meters above the ground. The ball hits the ground and rebounds to be assumed that air resistance is negligible. Calculate the speed of ball as it hits the ground.
Okay, so you should have okay, initial velocity, right, which is given as 8.4, right? 8.4। height आपको दे रखी है 5, right? और क्या, और what is the third thing?
So acceleration 9.81.
Very good, 9.81, fine. Which equation we can use
So,
to
so
find
we
the
can use
final?
2AS, right? 2AS1.
Yes, yes, very good. So
You'll
2as
need
is
to
equal
unlock your
to v square minus u square। खतरनाक घंटी रखी है तुमने तो। अच्छा जी, 2 into 9
iPhone. नहीं
point,
सर बोल रहा हूँ seriously.
वो उनका एआई वाला होगा ना कोई कैरेक्टर फीचर, ये मे बी। खैर खैर। सो द डिस्टेंस इज 5। ओके, एंड वी आर फाइंडिंग द फाइनल वेलोसिटी एंड इनिशियल वेलोसिटी को यहाँ पे ऐड कर देते हैं। 8.4 स्क्वायर इज इक्वल टू एन होल थिंग अंडर रूट। ओके, निकाल दो भाई कितना आता है।
Sir, 12.98.
12.98, so we can take it as 13. Okay, 13, 12.99 allow 13 to 2SF but not 12.9। okay, fine। चलो आगे आ जाओ। To reach the ground, okay, straightforward question, right? क्या इक्वेशन यूज कर लोगे?
Sir, speed equals distance upon time.
You come on, you are not allowed to use that formula over here, bro। acceleration के अंदर कभी भी speed equals to distance upon time यूज नहीं कर सकते हो, right? समझता है कि नहीं समझता है? यस।
Sir, एक मार्क के दिया वैसे sir.
Because they're look, whenever they ask you for the show that question, so they won't give you the answer mark. Okay, so since they have written the answer here, right? So they will not gonna mark, they're not gonna give you the answer mark, okay? Clear? So they will only give you the calculation, the showing of mark, right? And you have to put the answer mark as well, right? But you are not allowed to assume such type of question as being the easy one, or being applied, or just apply the simple formula instead of the other formulas, right? तो उससे गलत हो जाएगा. Clear? So
So
और
V is
याद.
V equals AT plus U.
Yes. Any equation of motion आप use कर सकते हो. This is basically v minus u over t. Fine. अच्छा जी. So 9.81, wait. T is the subject. Okay, but please keep in mind, whenever you have the acceleration in the system, you're not allowed to use v equals to distance upon time, right? Distance over time formula required constant speed, right? Zero acceleration. So final speed is 13. Initial speed is 8.4. 8.4 divided by the acceleration is 9.81, and निकाल दो भाई कितना बनता है.
0.468.
0.468, right? So it is 0.47. अच्छा. मैं
0.46.
मैं इसकी ना आपको मार्किंग की भी दिखाता हूँ, सही कि मार्क एग्जामिनर रिपोर्ट क्या कहती है. शो दैट वाले क्वेश्चन, अरे लो कुछ भी नहीं कह रही. लो छी. There was generally well answered, वरना एग्जामिनर इस पे बारे में बताता है कि शो दैट में ना बच्चों ने पूरी वर्किंग की शो की हुई थी. खैर, ओके, लेट्स मूव ऑन.
The ball rebounds vertically with a speed of 4.2 meters per second as it leaves the ground. The time the ball is in contact with the ground is 20 milliseconds. The ball rebounds to a maximum height h. The ball passes A at time t equals 0 on figure 2.2. Plot a graph to show the variation with time t of the velocity v of the ball. Continue the graph until the ball has rebounded from the ground and reaches B.
एंड रीचेज बी. ओके, फाइन. सो पहले तो हम कोऑर्डिनेट्स निकाल लेते हैं, सही है, फिर उसके बाद पॉइंट प्लॉट करेंगे, ग्राफ प्लॉट करेंगे, राइट? सो अगर आप देखो, सो इनिशियली at time t equals to 0, at time t equals to 0, the speed is 8.4, right? This is the first coordinate, or first piece of coordinate, okay? Now, when it is about to hit the ground, the time was 0.47 second. So at this point, the time was 0.47 second, and the speed of the ball was 13. Okay, this is the second coordinate. Okay, now इन्होंने क्वेश्चन के अंदर मेंशन किया दैट द टाइम द बॉल इन कांटेक्ट विद द ग्राउंड इज 20 मिली सेकेंड. ओके, 20 मिली सेकेंड मीन्स 0.002, राइट? ऐसे ही. फाइन. सो जस्ट एड पॉइंट जीरो जीरो
Sir,
टू.
you added one extra zero, 0.02.
नो, कम ऑन. ओके, सॉरी सॉरी. सही. 20 है ना, मैं 2 समझ रहा हूँ. ओके, 0.02. फाइन. सो दिस इज द टाइम फॉर विच द बॉल रिमेन इन कॉन्टैक्ट. ओके, and they're saying the ball rebound vertically. Okay, so as it start rebounding, or as it lose the contact from the ground, तो उसको टाइम कितना लगा होगा? 0.47 प्लस 0.02, राइट? सो ऐड करोगे 0.49 हो जाएगा. यस, 0.49. एंड corresponding time period, corresponding speed is 0.4 but the
So
direction
negative, right?
is changed. Yes, very good. So you have to put the negative sign. Okay. And as it reaches the maximum height, the velocity will be
Zero.
zero. Very good. And the time will be, I think the time is given. Uh, reaches, okay. Okay, fine. They didn't give us a maximum time, but we can assume that it takes double the time period. Okay. So just double it, so you'll get 0.98. Okay. You do not have to double 0.47. Okay, you have to double 0.49, right? Because you have to consider the contact time as well. Okay, now just consider all of the point and plot it. Okay, so if you plot, so ये आपको दिखेगा. um, okay, so until the ball. Okay, fine. अच्छा जी यार, ये तो प्रॉब्लम हो गया यार, इन्होंने कोई एक्सेस ही नहीं दिया हुआ है. Okay, 4 8 12. 4, 8, 12, and -4, -8, and 12, -12. Okay. And then point 0.2, point 0.4, point 0.6, point 0.8. Okay. So 0.2, 0.4, 0.6, 0.8, and 1, 1.0. Okay. Now, the ball is starting from 8.4 velocity, and at time t equals to 0. Okay. At time t equals to 0, starting from this point. Okay. And then at 0.47, 47 of time. Okay. It reaches a velocity of 12 and 13. Okay. So 1, 2, 3, 4, and 5. So 13 would be, अच्छा जी, यार ये तो प्रॉब्लम हो गया यार. पॉइंट्स में जाना पड़ेगा. इफ वी गो टू, अच्छा जी, और कुछ कर सकते हैं? कैन वी डू एनीथिंग? चलो यही ले. ओके. सो 12 एंड that would be 13. 5 divided by 4, 1.25. Okay, so 13 यहाँ पे कहीं पे आ रहा होगा. So at 0.47, at point 4.2467, at 0.47, it would be right there. Okay. Now this is the second point. Okay. And you can draw the line like this. Okay. Now it take 0.02 seconds to rebound or remain in contact with the ground. So you have to add a line of zero point zero 0.02, point zero 0.02, which is of one box. Okay. So it is very, it has a very steep gradient. Um, it should be like this, and it reaches 4.2 right
So
here.
you didn't change box.
Yes, you.
Okay, now.
Okay, okay. Now that's okay. So So this is how you should show the time for which the ball remain in contact, and then after rebound, it reaches to 9.98 would be right here, and the velocity will be 0, right? Like this. Okay, is that clear? Is the graph making sense?
Yes.
And if you find out the gradient, so the gradient should be 9.81, right, for both the cases. And if you find this area, so it should be equal to 5. It should be equal to 5. And if you find this area, then it should be equal to this height h. Okay. Is that clear? Yes.
Yes.
Perfect. Chalo. Okay, let's move on. Please read the question.
The ball has a mass of 0.050 kilograms. It moves from A and reaches B after rebounding. For this motion, calculate the change in kinetic energy.
Okay. अच्छा, बाय द वे एक मिनट दो मुझे जरा, मैं ये भी चेक करूँ. Reasonable shape, suitable scale, correctly plotted first and the last. Okay. Okay. एंड हाँ जी, हमने 0.96 पे बनाया. एंड विद नो वर्टिकल लाइन. ओके. हमने नॉन वर्टिकल बनाई. ओके. इट वाज अ टिल्टेड लाइन, राइट? अच्छा, बाय द वे, लेट्स सी व्हाट एग्जामिनर सेज. The graph was drawn incorrectly by majority of the candidate. Initial velocity was often shown to be 0. Okay, be very careful. Okay, they're not throwing they're not releasing the ball, and the velocity on the rebound was seldom. shown to be negative. Okay, the final stage from the ground to point B was often drawn with a line that has a gradient and was different from that line initial stage, right? So basically, you first have to make sure that the two lines should have the same gradient because they are referring the 9.81 gravity. Okay, and this should be tilted. Okay, and this should be starting from some velocity, right? If you release the ball, then it should look like this. Okay, is that clear? Now, okay, so they're saying the change in kinetic energy. So change in kinetic energy would be half m and change in the speed square. Okay, acha, be careful when they're asking for the change, then you should have to write the formula for the change and not just for the kinetic energy. Okay, and because sometime they detect the mark if you just write the kinetic energy formula instead and finding the change, right? Yeah, while finding the change. Okay, so half and m, which is 0.05, and v, so it moved from A to A and reaches B. Okay, so at A, if you look at A, so at A the velocity is 8.4, and at B the velocity is 0. Okay, so the velocity is 0 at B. So um 8.4, 8.4, which is okay, fine. Let me do final minus initial. So final minus initial, okay. It will give you the answer in negative, right? And that negative sign shows that the final kinetic energy is smaller than the initial kinetic energy, right? Okay, please calculate the value. Yes, how much?
So 1.76.
1.76. You can take it as 1.8 with a negative sign, and that negative sign again shows you the change, the loss in the kinetic energy. Okay, please move on. The the change.
Gravity. Okay.
Okay, okay. From here, okay. Calculate the change in the gravitational potential energy. So please write the formula for the change in GPE as um, mg and change in h, okay? Instead of writing just h, okay? Clear? Now, um, m is 0.05 and g is 9.81. Now, how we find the h? Any idea?
Area under the graph.
Okay, very good. So if we do area under the graph, so this will give us the this will give us this edge, okay? So and since we are finding the change, so we have to subtract 5 with that edge, okay? Yes? सही हो गया ना ऐसे ही?
So, but is there any like
Other way?
another way to solve for h?
You can use the equation of motion for that. Because you know the initial velocity as the ball rebounds, which is 4.2, and it reaches a maximum height where the velocity is 0. You know the acceleration as 9.81, and you can just use the equation of motion for that. Okay, so I'm rather using the equation of motion instead of graph. So it will give you the initial velocity as 4.2 with a negative sign. The no, not the negative sign. The acceleration is just negative 9.81 because you're moving up. The final velocity is 0, and you have to find out the h. S is equals to h. Okay. Which equation of motion you use? 2as, I think. Minus u square and um okay. So s is equals to v is u is negative 4.2 squared divided by 2 into negative 9.81. Okay, so negative and negative goes off. Okay, please tell me the value.
So 0.89.
0.89. Okay, so since we are finding the change, so 0.89 minus 5. Okay, final minus initial. Okay, so निकाल दो कितना आ रहा है.
So 2.
Exactly 2.
Yeah, sir, exactly 2.
Okay, Now they're saying the total energy of the ball. Hmm. State and explain the total change in the energy of the ball for this motion. Okay. So when the kinetic energy changes by 1.8 and the potential changes by 2, so the total change would be 3.8, right? And you have to negative sign that shows the total energy being lost, or the kinetic energy leaves the system, or potential energy leaves the system, right? It may be converted into some other form, whatever, right? So, um, okay, so the total change in energy should be 3.8, which which loses from the system from the system system when it basically loses during the contact, maybe in the form of heat energy, right? This is the system during the contact in heat energy. Okay, and that's it.
There can we say elastic because it's
If the
like
ball
it will.
has some elastic properties, then you can say that. And by the way, this thing shows it has elastic characteristic. Okay, so yes, you can say that, right? Otherwise, if it is a brittle surface, then it won't get the tilted shape. It will just hit it down, and then eventually it rebounds. Okay. Uh, they didn't say any, didn't mention the nature of the ball, by the way, but let's see कि exam report क्या कहती है and what the marking key says. Okay, look. They're saying kinetic energy at the end is zero. They included the formula for the change. Okay, for both the gravitational potential energy and kinetic energy. Okay, and they're giving you 1 mark for the formula, and they're giving you formula and calculation, and the other mark for the answer, right? If you put the answer directly, if you calculate the answer directly, then you won't get any mark. Okay, so fine. Okay, they're saying loss impact may or okay, the ball deform. Okay, thermal energy. Fine. You c- you can say that. Okay, so just read these last three part. So the examiner says majority of the candidate calculate the change in kinetic energy using the initial velocity and the rebound velocity rather than the velocity at point B, which was zero. Okay, this was the main error that the student did. Some candidate calculate the change in kinetic energy using half m v2 minus v1. This is not the correct formula. Okay, you cannot take a square common. Okay, the correct formula is half m v2 squared minus v1 squared. Okay, so be careful, right? A well-prepared candidate calculate the rebound height and then change in the potential energy. A significant number of candidates calculate the potential energy at one particular height and not the change in the potential energy. Right? They uses five, and they use five and they find out the potential energy of the first system of the first before the rebound, and they didn't find it after the rebound. Okay, for the last part, very small number of candidates give the numerical answer. Okay, you have to give the numerical answer for the total change in the energy. The majority of the answer were not accepted. The majority of the answers were not acceptable at this level. Okay, the energy change should have been linked to the particular system or body rather than this loss at heat. Okay, this is what we said, I think. The energy changes should have been linked to the particular system or body rather than lost as a heat or sound. Okay, so we said, um, बल्कि we also connect the system, right? At which loses from the system during the contact. Okay, fine. So during the contact with the ground will connect the whole thing with the with a question. Okay, let's move on. Ajavi, Irfan, please read the question.
State Newton's first law.
First law. Can you? Yes, we say a body continue continues its state of rest or motion with constant velocity, okay, until it is exerted exerted by uh, external force, external force, okay. And you have to be very careful at this level because they're asking for the laws, and laws have to be very precise, very accurate, okay. Let me show you the examiner's comment, okay. The law was generally stated in an unacceptable form at this level, okay. Is that clear? So most of the good student, uh, they they do a lot of calculation, but when it comes to the to writing the definition, so they just lose a lot of mark, okay. So you have to be very precise while writing the definition and laws, okay. And for that you can consult the examiner report, so where they highlight many problems, okay. Very few stated the constant velocity should be constant, and resultant force should be zero, okay. And you have to mention that, okay. If you don't say that, if you just say a body continue its state of rest or motion until it exerted by the external force. So this is not the not the Newton first law. Okay, so please careful. Right? Okay, let's move on. Irfan.
A log of mass 450 kg is pulled up a slope by a wire attached to a motor, as shown in figure 3.1. The angle that the slope makes with the horizontal is 12 degrees. The frictional force acting on the log is 650 Newton. With reference to the log travels with constant velocity. With reference to the motion of the log, discuss whether the log is in equilibrium.
Okay, so discuss whether the log is in equilibrium or not. Okay, so they're saying the log travel with a constant velocity. Constant velocity means yes, Irfan. Acceleration would be zero. Yes,
Yeah.
and the frictional force is also acting fine. So the forward force that is in the wire, which should be tension in that direction, and the backward force that is the friction, by the way, which is 650 plus the component of the weight. If they both balances out, then you can say that the log is in the equilibrium position, okay. So but since they're saying the log is moving with a constant velocity, so we don't have to do any further calculation, okay. So we are saying the log is traveling with constant velocity, which means which means zero resultant force, zero resultant force. अच्छा जनाब, and so it is in equilibrium. Okay, and you can check the examiner report for that because it is the writing questions. So, a small minority of the candidates were able to link the constant velocity of the log with a zero resultant force. Okay. A significant number suggested that the log was not in the equilibrium as it is moving in the constant velocity. Okay, this is an incorrect form. Most of the candidates think that when something is moving either with a constant velocity or without a constant velocity, the both conditions are like they consider both condition as not as a Newton's second law condition, as a resultant force present condition, right? So this is not the case, right? In the first case where you are moving with a constant velocity, you won't have any resultant force. Okay, fine. Let's move on. So they're saying calculate the tension in the wire. Okay, so for the tension in the wire, since it is in equilibrium, so all the upward forces should be equal to all the downward forces, all the rightward forces should be equal to all the leftward forces, right? This is a common sense, and just make the component. So okay, and okay, now so that would be 12. That would be 12, and they're saying the weight is given as the mass is given as 450, right? So 12, sorry, 450, 450 cos, uh, sorry, into 9.81 we got into 9.81 and cos 12 and 450 into
So you
9.81.
need to do this to get the tension.
Yes, sine 12. Okay, look how. So at
Isn't it
equilibrium,
the other way around?
how
This
the sine and the cos
the
component are.
yeah, shouldn't this be sine the 450 into 9.81 sine
No,
12?
actually, look. Actually, the diagram is this way. This is the actual weight, which is 450 into 9.81, right? And this is the component, okay? And this is the vertical component, like the component vertical to the plane, okay? And the angle in between these two is 12, okay? So that is why I'm saying, because this will become the base now and cause work with the base or work with the adjacent, okay? And this is a sine, okay? Okay. So this will be, if I'm clear,
Yeah, yeah, got it.
so this will be 12 cos 12 and that will be sine 12. Okay. So we are saying at equilibrium, um, you know that the forward force should be equal to the backward force, or you can say the forward force minus backward force should be equal to zero. Backward force. Okay. Now the forward force is the only tension we have, and the backward force are the two forces, the friction acting in the opposite direction and the parallel component of the weight. Okay. So 650 plus 450 into 9.81 cos or sine? Sine 12. Okay. How much? Yes, Irfan, how much? Anyone's calculating? Guys,
Give me
quick.
1 second. 751.
As a total answer?
Says the tension.
The tension is 751. How?
I'm getting
So
1600.
1000. It should be because like 600 is this one. And how can you add this one to okay.
sir, it's is it U50 or 150?
अबे वन 450.
अच्छा 450.
अबे यार कम ऑन.
जी
450.
सर 1567.
1000. Okay, so we can write 1600. Okay. Okay. Irfan, move on, please. Yes, quick. Irfan, कहाँ हो यार? Where are you? So say explain whether the gain in the potential energy per unit time for the log is equal to the output power of the motor. Okay. So gain in gain in the potential energy per unit time is actually the power. Okay. Is actually some kind of power, right? Because power is supposed to be the energy over time, right? So this is the potential energy over time. So this is a type of power, but we have to figure out whether it is going to be the total power or equal to the output power or not, right? So basically, over here we have like the motor doing a work, right? Motor is lifting the log, as well as the motor is overcoming the friction and the component of the weight, right? So so basically the output power should be smaller, right, than the input power. This is the first thing. Some portion of the input power get converted into, or like get lost in the form of heat, right, due to the friction. Okay. So okay, so acha janab, so we have to say that there, by the way, law equal to the output power of the motor, gain in the potential. So अच्छा now we can say that कि यार ये ऊपर ही हथौड़ा मार रहे हैं, बिल्कुल अजीब पागल आदमी है. अच्छा जी, खैर खैर खैर. So the friction force causes some of the potential energy to lose in the form of heat, in the form of heat heat. So the output power, so the output power has to be has to be greater than the potential energy per unit time. Potential energy per unit time. Guys, is that clear? Right. So basically, look, or basically this is the output power, right? This is the output power. Okay. This is the output power. Okay. Now, some of the output power is getting converted into the gain in potential energy, and some of it getting converted into the the thermal energy, right? Thermal energy, right? So and the output power is basically the combination of the two, right? So if you compare the potential energy, like the potential energy over time, because power is the energy over time, right? So if you compare the potential energy over time with the output power, so output power has to be greater than the potential energy over time, right? Clear? Okay, we are done with that. Let me show you the. Okay, so this is correct. And okay, fine. Let me show you the examiner report first, and then we'll move on to the. Okay, this one. Okay, part two and part three. A significant number of candidates calculate the component of the weight of the log acting downward down the slope, which was the cost component. Many candidates then equate their value to the tension in the wire without any reference to the frictional force. Okay, you have to be very careful. You have to include all the forces. Okay, or subtract the frictional force from their value, despite having use of 9.81. A significant number of candidates use 10 in their parts. Okay, so you have to use 9.81 for the conversion of mass, okay, instead of 10, right? And then you have to consider the parallel component that should be calculated from the sign and not the cos. Okay, now the last part, well prepared candidate were able to explain the difference between the power produced by the motor and the gain in the potential energy per second by describing the work done against the friction. Okay, I said the thermal energy. Okay, against, okay, answers that were merely stated the energy is lost to the friction heat, this is what I said. So, and they're not liking it. Okay, so answers that were merely stating that the energy is lost to the friction or heat were not given credit. Look, I won't get credit, any credit, or maybe one credit. Some candidate ignore the effect of the frictional force, suggest that the two were equal as. Okay, fine. Let me just correct my answer. Okay. So they're saying frictional force causes some of the potential energy to lose in the form of heat. Okay, no. Okay, I'll get mark because I said the frictional force causes some of the potential energy to lose in the heat, or some of the potential energy, or some of the motor's energy, right? So that's why. So the friction, it should be a little bit of incorrect. The frictional force causes some of the um, instead of writing the potential energy, I have to say the um, output output energy of motor, right? To lose in the form of heat, so the output power has to be greater than the input potential energy. Okay, fine. Chalo, let's move on. Okay, Imad, please read the question.
Battery evaluation with a force 12 volts and negligible air resistance. Internal resistance is connected to two resistors and the LDR as shown in figure 4.1. An ammeter is connected in series with battery. The LDR and switch S are connected across points X and Y. The switch S is open. Calculate the potential difference across XY.
Across XY. Okay, so if the switch is open, so the circuit, you should visualize the circuit in this way with only two resistors intact. Okay. अरे बाप रे, माइक तो बंद कर ले बे. अच्छा,
Sorry,
खैर
sir.
खैर खैर खैर. रोजा यार, सब माफ है, कर लो जो कर लो. Okay, so two resistors, and we have the battery. Okay, so you have to visualize the circuit that way. Okay, now, so this point is X, this point is X, and this point is Y, right? So calculate the potential difference across X, Y, right? So you can use the formula V out is equals to R of xy, right, divided by r total, right, plus, sorry, times v in. Okay, so rxy is 12k and total is 20, right? So 12k, 12k, I'm not converting, total 20, but okay, let you have to cut, we have to put that way. Okay, don't.
Sir, can we use
Yes,
the ratio because it's in series?
I am using the ratio. This is the ratio, bro. Like you say, the total voltage across the total resistance, so how much voltage will be there across xy? Yes,
Yes.
this is what we are doing, right? But it is just like the formula. Okay, so that's why it's just the formula, that's why you get confused. Okay, now, so how much? 12 divided by 20 into 12, 72, 7.2, yeah, 0.72, 7.2 over, it should be 7.2. Yes,
Yes.
good. Okay, let's move on, Imad.
The switch S is closed. The resistance of LDR is 4 kilo ohms. Calculate the current in the ammeter.
Calculate the current in the ammeter. Okay. Now, they are saying the switch is closed. Okay, fine. Calculate the current in the ammeter. Current in the ammeter means current in the battery, basically. Okay. Current in the battery, a total current. Okay. So this is mean the
Yes.
total current. Total current. So for the total current, you have to find the total resistance. Okay. So total resistance is going to be first you have to solve the parallel combination 1 over 12 plus 1 over 4, that will be 3 over 12, 4 over 12, 12 over 4, and 12 over 4, 3. Okay, so 3 kilo ohms will be the R of R parallel resistance. Okay, will be the parallel resistor. Okay, now add it with the total or with the series one to get the total. So our total would be the other one is 11. Okay, it will give you 11. So 8k, you have to put exponent 3 instead of k, plus 3 exponent 3, so it will give you 11 exponent 3, and then use v equals to IR, and then voltage is 12, 12, and divided by 11 exponent 3. How much? The current is how much?
So are you supposed to get it in standard form?
Standard form, yes. Like
Sorry,
in the calculation or at final stage?
so at final state, like the answer.
Yeah, yeah.
So 1.09 power negative 3.
1.09, so 1.1 exponent negative 3. Fine. Let's move on.
The switch S remains closed. The intensity of the light on the LDR is increased and explain the change to the ammeter reading.
Okay, so when the intensity increases, what happened to what happened with the resistance of the um LDR?
So the intensity light increases, so the resistance decreases.
Very good. So if the resistance of parallel path decreases, so the overall resistance would be higher or lower? Like, let's assume that the intensity decreases. So previously we used 4. So now we have to do 1 over 12 plus 1 over 2 instead. Let's say it decreases to 2. So we have to do 6, 6, and then it becomes 7 over 12 and 12 over 7, 12 over 7, right? So it reduces, right? So the total overall resistance of the circuit reduces, so which reduce the current, which increase the current. Okay, clear?
Yes, sir.
Perfect. So I'm saying,
Sir, also can you explain when it says like across XY, which one do we take? I don't understand that part.
what? Like this one? This one?
Yeah, yeah, XY. What does it mean?
Like you connect the voltmeter across this part, okay, and you're finding the voltage across XY, right? Without having this resistor in, right? Like you can for now you can ignore this one, like this, like that, okay? This is the circuit for the first part, okay? Clear?
Okay.
And then you have for the second part you have this one, okay, fine. Now, at higher ammeter reading, sorry, higher the intensity, lower the resistance of LDR, which decreases the overall resistance of the circuit of the circuit, so current will increase. Okay, let's move on. The potential difference across xy. Okay, so across xy, across xy, across xy. Okay, so when you increase the resistance, when you decrease the resistance of LDR, so the overall resistance decreases, right? The overall resistance with this path decreases, so the potential difference will also go down. Okay, clear? The the combined resistance of LDR and 12 kilo ohm resistor decreases, right? So PD will also be lesser, will also be lesser, right? Let me just see the marking key really quick. 7.2, 1.1. Okay, in current greater, potential different lesser. Okay, इसकी examiner report देख लेते हैं for the last two part. Okay, this part was generally well answered. A minority candidate were unable to calculate the total current. Okay, fine. For the C1, where we wrote the things down, large number of candidates did not make their explanation clear. There were many vague, many general statement about the resistance decrease without making clear reference to the resistance of the LTR or the resistance of the complete circuit. Okay, so I made everything clear. Okay, the significant number of candidates incorrectly state that the resistance of LDR would increase. Okay, they are actually inversely proportional. Okay, so if the intensity increases, the resistance goes down. Okay, fine. Well prepared candidates were able to explain that the resistance in the parallel section would decrease. Oh, I am well prepared, man. Okay, fine. Very few candidates were able to explain why this would cause the proportion of the voltage available for the power supply to be less than in A, right? Because in A you don't have that LDR intact, right? Because the switch was open. So when you close the switch and decreases the current, decreases the resistance, so the overall resistance decreases, the potential difference also decreases. Okay, start. Let's move on. Last two question, I think. Last two question. Yes. Yes, Irfan. Yeah, yes, Irfan. You have to read. Quick.
Define Young's modulus.
Young's modulus.
It's
Irfan.
a ratio of stress over strain, right?
Very good. Ratio of stress, and strain. Okay, since it is a definition, strain. So I just want to really quickly check okay, marking key is not that much useful. Majority of the candidate gave the correct definition. Okay, they're not writing anything. Fine, let's move on. Yes, Irfan, quick.
A load F is suspended from a fixed point by a steel wire. The variation with extension X of F is for the wire is shown in figure 5.1. State two quantities other than the gradient of the graph in figure 5.1 that are required in order to determine the Young's modulus of steel.
Okay. Acha ji, so if they're asking you for the Young modulus of the steel, so they have given you the graph for the force and the extension. So what will be the gradient of the graph gives you? Yeah,
The spring constant.
very good. The spring
Okay.
constant or F over X or K, right? Very good. Now, is there two quantity other than the gradient of the graph that they are required in order to uh, determine the Young modulus of the steel? Okay. So remember the formula for the Young modulus? E equals to FL over AE, right? So we required the original length, right? Original length, right? And we required the diameter or the area, okay? Diameter or the area, right? Okay, let's move on. Describe how the quantity you listed may be measured, okay? Length can be measured using the ruler, meter rule, and diameter can be measured using the vernier caliper. Okay, so
So
uh,
using what?
vernier caliper or screw gauge, micrometer screw gauge. Did you guys
Sure.
heard the name?
So I had micrometer, but not the overgear.
Vernier caliper, okay, and micrometer screw gauge. Okay, okay, you can say that. So original length is a micrometer is more accurate, vernier caliper is less, then meter rule is lesser, then a tape measure is least. Okay, so okay. So length can be measured using meter rule, and diameter can be measured using micrometer. Okay, let's move. Should we check the marking key? Okay, just move on. Yes, Irfan.
Yeah, sorry, my
Like, okay, then.
internet's bad. A load of 3 Newton is applied to the wire. Use
Okay,
figure 5.1 to calculate the energy stored in the wire.
okay. So they're saying energy. Okay, so for the energy, you have to use area under the graph. Yes, and they're just saying okay till three, which means this area. Okay, so the extension is going to be 0.25. Okay, and it is in millimeter. So you know that. Acha, when you're using the figure, just write down the feature of the figure that you're using. Okay, so energy stored is equal to the area under the curve. Okay, now it is a safe side for you to solve now. Okay, so 3 is a force and 0.25 exponent negative 3 is the area is like the extension, and okay, please calculate.
3.75 into 10 to the power minus 4.
Okay, 3.75 means 3.8. 3.8 exponent negative 4. Fine. Okay, let's move on.
A copper wire has the same original dimensions as a steel wire. The Young's modulus for steel is 2.2 into 10 to the power 11 nanometer. No, sorry, Newton meter.
Millimeter, yes.
And for copper is 1.1 into 10 to the power 11 Newton meter. On figure 5.1 gets a variation with x of f for the copper wire for extensions up to 0.25 millimeter. The copper wire is not extended beyond its limit of proportionality.
Okay. So basically, they're saying copper wire for the copper wire, and they actually told you half the young modulus. Basically, these are half the young modulus. Yes. So with the original dimensions of, if you write the formula, F is equals to FL over AE, which mean have the same the original dimension. Original dimension means k l remains the same, right, for both the cases, and a remains the same for both the cases, right? So f over e is the thing changing, so basically your gradient will be exactly half of what they just drawn there. Okay, okay, so that will be 3, so 1.5, so 1.2, 1.5 right here. Okay, and this is the graph. Okay, is that clear? Okay, it is done. Let me just look at the marking examiner report first. Um, Question number five, you were doing the definition was correct. The significant number of give both required quantities. Candidates should be encouraged to give full description of the quantity to be measured. Okay. In this case, quantity required is the original length and the cross-sectional area. Okay. So a better way to write the cross-sectional area, or I just said the diameter, so it work. But a better way is to say the cross-sectional area instead of the area. Just give me a second. Okay. So okay, original length ये सारी चीज़ हमने देख ली हैं. You can just read it. Okay. So आ जाओ, let's move on. I think last question. One. Okay. Two questions left. Okay. Imad, please read.
Use the principle of superposition to explain the formation of a stationary wave.
Yes.
Sir, when two waves of same type overlap,
Mm-hmm.
the the resultant displacement is the individual sum of the wave displacement.
Okay, but we have to make the stationary wave. Okay. So
Sir,
you have to say,
coherent
huh?
coherent waves.
Okay. When two. Okay, you can say that when two coherent wave, or you can say when two wave. Uh, when two wave of the same type moving in the opposite direction. You should have to mention the directions. Okay. Opposite direction with same frequency, speed. Yeah, same frequency, wavelength, and amplitude. Same frequency, wavelength, and amplitude. Amplitude, tude, and superimpose. Superimpose. Okay. So, uh, the resultant displacement displacement would be, so since they're asking you to relate with the superposition law, so that's why I'm saying the resultant displacement, which is the superposition, the resultant displacement of the stationary
Sir, will they form anode and
anode.
antinode?
No, why? Kaddu. Anode, just node. Anode is in chemistry.
Oh, sorry.
Okay, so the resultant displacement of the stationary wave, um the stationary wave. You can say the resultant displacement of the stationary wave will be sum of two waves, two waves, producing producing nodes and antinodes. Yes, nodes and antinodes. Okay. Okay, let's move on.
Describe an experiment to determine the wavelength of sound in air using extension waves. Include the diagram of the apparatus in your answer.
Okay.
Here's the tube one.
The tube, no. Just look, just have a bench. So this is your bench, okay? And you don't need to make the three dimensions. So, and put a metal reflector, okay? And a sound source, okay? A sound source, okay? And a microphone, a movable microphone, okay? And this movable microphone should be connected with the, okay, it should be connected with the CRO, right? To measure the waves, okay? And this is the speaker. The speaker is made this way mostly, right? So, and you have to label. See, so this is the speaker, right? And this is the microphone, right? And this is the metal reflector, metal reflector. Okay. Now, what happened? The wave will be generated like this. Okay. Man, come on. Wait. Okay. So, so you have to draw the wave by the way, no? Or wait. So, fine. I am just moving my reflector to this point. And when they get reflected back, so you'll see the wave like this, right? Like this, and like this, and like this. Okay. So this is the stationary wave that forms. Okay. Now, just mark down some of the things, okay, and explain it now. Okay, so they're giving you 3 mark. Okay, so I'm saying that uh, sound wave can be generated. I'll see the examiner report. Okay, sound wave can be. बे यार एनर्जी क्यों लिख रहा हूँ मैं generated using speaker uh, at travel um, and hit the reflector, okay, the incident and reflected wave overlaps, okay, the incident and reflected wave overlaps, okay, producing nodes and anti-node. Okay, but how you anti-nodes? Okay, so how you or rather say producing loud sound and low sounds. Okay, producing loud and low sounds. Okay, which can be which can be detected detected using movable microphone microphone microphone. Okay, the microphone connected with the CRO, right? So on the CRO screen you can see the wave. Okay, and low sound and high sound. Okay, so microphone. Okay, clear. Okay, now let me just see the examiner report for that. Okay. So the first part explanation of the stationary wave was not given in a sufficient detail by majority of the candidate. Many suggested that the wave needed to superpose or interfere instead of meet or overlap. Okay, so they're saying meet or overlap instead of superpose. Okay, so okay, fine. So I have to correct this thing in my words, in my answer as well. Okay, so they're rather saying instead of meet or okay. So meet and overlap is the best word. The principle of superposition was generally given correctly, but some candidate can give an incomplete statement or add amplitude rather than displacement with no credit. Okay, fine. इसको मैंने correct करना है. The second part is the part where generally poor answers. Many apparatus was often incomplete and not clearly labeled. A loudspeaker should be include a signal generator. Okay. I didn't have the signal generator to reduce the sound of the variable frequency. Okay, many omitted the adjustments. So many omitted the adjustments to obtain the resonance and the distance between adjacent node and anti-node would often not linked with the okay. So my answer is not. My answer is also considered a poor answer. Okay, so now let's make it better. Okay, so so a speaker should be connected. Wait.
Sir, where is the CRO here?
Actually, I didn't draw the CRO. I just said that it is connected by the CRO. Basically, look, let me just make the signal generator. Okay, let's say this is the signal generator. Okay, and the signal, okay, so the signal generator will produce the sound of the varying frequency, right? Because you cannot have one frequency that produces the either you can say that change the distance so that the stationary wave forms, or either you can say that a loudspeaker signal generator to produce the sound of the variable frequency. Many omitted the adjustment to obtain the resonance. Ajay, and the distance between the adjacent node and okay, fine, so they're not including that. Okay, so I am just adding the signal generator. Okay, that generator will produce a variable frequency sound. Okay, now and you have to measure the distance. Okay, so connected with a CRO. Now I have to write um I have to write measure measure the distance between two um loud sounds, or yeah, just two loud sound or two low sounds. Okay, um and multiplied by two. Wait, इन्होंने कहा है they're saying Determine the wavelength. Okay, multiply by 2 to get the wavelength. Okay, wavelength. Is that clear? I hope so. It should be clear now. And this way, the whole apparatus is also complete. Okay, so fine. By the way, the microphone should be connected with like the CRO. The CRO looks like this. You should remember the picture of the CRO we made in the lectures, right? So you have the screen, the big screen, and the Y the time base setting and the Y gain, right? These are the two buttons that you have to draw, right? And you can just connect it with a microphone, okay, like this. Fine. So it will read you it will read you off the waves, right? So this is the CRO, right? Clear? Okay. Any problem? So using the CRO, you can find the distance, right? Or using the meter rule, you can find the distance, right? Okay. So now it is done. Let's move on to this one. Okay, read the question, please.
The variation with distance x of the intensity I of a stationary sound wave is shown in figure 6.1. On the x-axis indicates the position of all the nodes and antinodes of the stationary waves. Label the nodes and antinodes.
Okay. Now what you do?
The antinode is like the top
Okay.
part and
And
node is the bottom one. Two nodes and two
node.
antinodes. Three nodes
Okay.
actually.
So node should be formed at the minimum intensity. Okay. So you're saying node there, a node here, and a node here, right? And an antinode here and an antinode here, right? Okay. They're saying the speed is this much, find the frequency. Okay. What to do?
We shall find time period.
How? We can use this figure to find out the to find out the wavelength, right? Rather than the time period.
Oh, I
What you do for to find the wavelength?
Sir, wavelength. You find wavelength?
So if you find like you have to figure out the wavelength, but this is not the wavelength, okay? This is not the one complete wavelength. Okay? Clear? Or this is not the one complete wavelength. You have to figure out first, okay? Look. Bye. So basically, you first have to redraw this graph. Okay. So when you redraw this graph, so wait. Now at node it is 0, okay? And at antinode it is maximum and then okay. This is the first loop, right? Where this is the node, this is the antinode, and this is the node, okay? Is that clear? And over here we have the amplitude and distance graph, right? Distance graph. This is the intensity distance graph, okay? And then for the full wave, it should look like this, okay? Right? So this is the node, sorry, this is the antinode and this is the node, okay? Now, this whole length till this point is basically the total length, okay? The wavelength basically, right? So to find the wavelength, to find the wavelength, you have to work out
Sir, we
for
can just
the whole
draw a
thing.
mean position at 0.25.
Sorry?
Can we draw a mean position at 0.25?
No. Oh, look, bro, the graph is not the same as because the graph is the intensity graph, okay? So you cannot find the wavelength from the intensity graph, okay? So you always have to you always have to find the convert the graph first into amplitude distance graph and then you can find the um, you can find the wavelength. Okay, clear? Or just keep in mind if they have given you the intensity time graph, so one wavelength or intensity time graph is actually in real is actually half the wavelength. Okay, So one wave over here basically refer half the wavelength, okay, in reality. Clear? So if we find out this distance, which is approximately 30, 31, 32, 33, 34. So 34 is basically, this is lambda by 2, which is equal to 33, 34. Okay. So if you multiply by 2, you'll get 60, 68. Okay. So lambda is 68. Okay. Speed is, Imad, did you get it?
Sir,
Yes.
can you explain again?
Look, please remember this thing. If they give you the intensity versus the distance graph, so one full oscillation show you half the wavelength. Okay, clear? Yes, any problem?
Yes, no
And
problem,
why
sir.
this is so? Because because wavelength is basically related with the amplitude distance graph, right? So if you convert this graph into amplitude displacement graph, you will find out that half the wavelength for the amplitude distance graph would be the full wavelength for this graph, right? So that's why. Clear? So just remember the rule, okay? So V equals to F lambda, okay, and 340 divided by 68 is equals to frequency, okay? Just find it out quick.
5.
5 is straight 5.
Yeah.
Wait. This is 5 exponent negative 2. Yani 68 exponent negative 2, so 500. Clear?
Okay.
Exponent negative 2.
Uh, why did we have to multiply by 2 the wavelength?
Bro, whenever they give you this graph, one wave for the intensity distance graph will always give you half the wavelength. Okay, is that
Okay.
clear? Okay, this is the rule. Now whenever, just check the unit first. If it is the intensity if it is intensity distance graph, then you have to multiply like whatever the full wavelength is by 2 to get the actual full wavelength. Okay, clear?
Yeah.
Fine. Just move on. Wait. Let me show you the examiner's comment on this question. Part C. Okay. So part C, part one. Okay. C, part one. Only a small number of candidates were able to correctly interpret the graph. Significant number of candidates appear to have read the text carefully in the figure 6.1 carefully and assume that the graph was of the displacement against the distance rather than the intensity against the distance. Okay. Okay. The distance between the two adjacent nodes or two adjacent antinode was linked to half the wavelength by only a small number of candidates. Baap re. Okay. So you can also see that if you make the loops for the stationary wave, if you make the loops for the stationary wave, okay, and over here we have the node and we have the node and we have the antinode, okay. So you can see we have the node, and we have the antinode. Look. So this is basically half the wavelength. Okay. Is that clear, guys? Imad Irfan? Quick. Yes.
Sir, is this only for the intensity
Yes,
graph or F
only,
for
only.
everything?
No, only. Intensity or intensity squared graph. Okay. Clear?
Half the wavelength or full wavelength?
Half the wave. Wait. Full of this wave will give you half the wavelength. Okay. Just remember
Okay,
with this
sir.
concept. Just draw the stationary wave. If you have the two node, between the two node there is only half the wavelength. Okay, this is what we discussed in the stationary wave. Okay, clear?
Okay, sir. Right. Half wavelength there on top. I got confused.
Okay, so this is basically half wavelength, right? Wavelength.
Sir, वहाँ पे नहीं sir.
And
The stationary wave you drew. Yeah, there.
this is also half the wavelength. Okay, clear? Any problem?
No.
Two loops combine to form one wavelength, and one loop is like a half wavelength. Okay. Now, okay, last part. Last question, two part. Yes, Irfan. Okay, you don't need to read, just tell me the answers. Straightforward. W is a neutron, so neutron has one nucleon number and zero proton number, and that is okay. The Y should be 235, 235 plus 1, 235 plus 1 gives you 236. On this side should be equal to 93 plus 141 gives plus Y gives you how much? 236 minus 93 minus 141. Yes,
So what does it mean when it says it absorbs a neutron?
like it just eat the neutron like that. Like the nucleus of the uranium atom absorbs the neutron and become more unstable, and then it start fission reaction. Okay,
The cell will the proton number change? I mean that yeah.
the proton number of the uranium atom,
Yes.
yes, it get changed and then it decays. That's why basically I'm just using the law of conservation of nucleon number. I just add 235 and this one to get 236. Okay, right? And now,
Is that this 92 minus 37, right?
yeah, yeah, very good.
55.
92 minus 37, 55. 92, 37, 55. Okay, perfect. Now let's move on to uh
The sum of masses of the left hand side of the equation in A is not the same as the sum of the mass on the right hand side. Explain why mass seems not to be conserved.
okay. So basically, some like the neutron will be moving, right? So they will have some of the kinetic energy which come from the mass, okay? So that is why. This is the reason, okay? Basically, this is the mass energy conservation law, okay? Like in the nuclear reaction, we say that not the mass of the product should be equal to the mass of the reactant only, but we say the mass and the energy, like when the product generated or when the product being produced, so most of the portion of their product start moving, right? Like the way something explodes, so all the things start flowing in um moving in the opposite direction, right? So the similar case is right here. So so that is why so the mass energy energy of the product of the product should be conserved, right? But not just the mass, okay? Because some mass will be convert or some mass converts into kinetic energy, right? So that is why, okay? And which makes the particle start moving, okay? Fine. So, yep, that's it, guys. So this paper is done. And by the way, your homework, please note down the homework, okay? So you have to do June, June 12, June 2012, 2012, 21, and 23. If you done any of them, then just skip the variant, okay? But you have to do the 21 and 23 variant, okay? Is that clear, guys?
Yeah.
So
Okay.
we'll send it to you.
Sorry. Yes, you have to, once you guys done, you have to make the PDF of the paper and you have to send me. Otherwise, I won't let you in the class. Okay. Be careful. Not by tomorrow, but by the next week. Okay. This homework has a deadline by the next week. Next Saturday, you guys have to submit these two papers. Otherwise, I won't let any of you sit in the class if you guys don't submit the paper. Because I have to be little strict with you guys because this is like the end of the time, right? So be careful, okay? चलें जी. Okay, guys, take care. Allah Hafiz.
Bismillah.
Allah
Love
Hafiz.
is.
Allah Hafiz.